Once again, good morning and welcome to our general mathematics class. Today, we'll learn about functions, and this is an introduction. To start with, let us say our memory verse for the day. It's found in Mark 10, verse 9. It says, "What therefore God has joined together, let no man separate." And your MVCA boosters for the day, you're in your forum, it's very related to this memory verse. You will name three pairs or three couples in the Bible that will represent a function. Now, at the end of this class, we'll be able to define functions and related terms, determine if the given relation represents a function, define a piecewise function, and the last is represent real-life situations using functions including piecewise function. Now, have you noticed the prices of bananas? Like when we compare it, what have you noticed in the prices of different banana varieties? Anyone? Anyone can share? What could have affected the price of the banana? Like in this graph, if you see in 2017, the green one, you'll see the price of the banana is going up. Then for the yellow, for 2018, in different varieties of bananas, it also varies. So what could have been the affecting factors? Shall I call a name? Here, Jovelyn. Can you share with us what could have affected the price of the bananas? Or shall I hear from Neil Bryan or from Hart? Or if you're still too shy to share, you can also chat it in our chat box. No, I'll expect answers afterwards, okay? Now, we have two big words to learn today. One is relation, and the other is a function. We have been learning this since grade 8, relation and function. Now, what is a relation? Like we have the word relationship. A relation is a set of ordered pairs. Just like in the usual relationship, you could not just have a relationship with only one person. It goes with a pair. So a relationship with someone, it's a set of ordered. Now, in a relation, the set of all x's, or the first coordinates, we call it the domain, while the set of all y's, we call it the range. For example, we have this one. The set of all first coordinates, the 1, 5, and 8, we call this the domain. And the set of all your y's, like A and B, we call this the range. Now, there are two ways to write a function, actually three. First is, you can write it in an ordered pair, like 1A, 2B, 3C, 4D. And our domain is the first, all the x's, 1, 2, 3, and 4. While the set of all your y coordinates, like A, B, C, and D, is called your range. Another way to write a function is through mapping, like this one. We map 1 to B. It means we pair, or we map 5 to A, or we map 8 to B. Or another way to write it is through a table of values. We have the X and the Y. So this is a relation. It's a set of ordered pairs. Now, what is a function? A function is a special kind of relationship. Now, we say that all functions are relations, but not all relations are functions. Now, when is a relation a function? A relation is a function if for every value of X, there is a unique value of Y. Now, let me simplify it. A relation, an ordered pair, is a function if the X coordinate does not repeat. Again, the X coordinate does not repeat. Let me give you an example. Here, in the first one, let's check all the X coordinates. Again, only the X. 0, 2, 4, and 6. Our X coordinate does not repeat. Therefore, this is a function. Another one for the X coordinate alone. 1, 1, 1. It repeats. Therefore, this is not a function. Another one. 0 and -2. 0 and -1. The X repeats. Therefore, this is not a function. Another. 1D, 2B, 3A, 4A. Ma'am, the A repeats. Yes, but it's only in the Y coordinates. We're just looking at the X. Is the X repeating? We check. 1, 2, 3, and 4. It's not repeating. Therefore, this is a function. Now, what if the given is a graph? How will you learn? How will you know if the function, the graph is of a function? Now, we have what we call the vertical line test. If you say vertical line test, it says that you draw a vertical line in the graph. If the vertical line only crosses the graph at exactly one point, then that graph is of a function. Example, like this one. You draw a vertical line, it passes in 2 points. Therefore, it is not a function. This one, you draw a vertical line, it only crosses by 1 point. Therefore, this is a function. And the next one, you draw a vertical line, it only passes the graph once. Therefore, this is a function. And the last one, you draw a vertical line, it crosses the graph on 2 points. Therefore, this is not a function. Again, you draw a vertical line, if it crosses the graph at exactly 1 point, again, 1 point only, it is a graph of a function. Any questions? Again, if you have questions, please feel free to raise your hand, okay? I really welcome questions in class. Let's go to the next one. But here's a note. Not all relations are functions. When is a relation a function? Let's have a very brief review. A relation is a function if the X coordinate does not repeat. And if it's in a graph, when you draw a vertical line, It only crosses the graph at exactly 1 point. Now, let's go to different types of functions. Just skip this one. Let's go to 9 different types of functions. We have linear, quadratic, constant, identity, absolute, rational, exponential, logarithmic, and piecewise. Actually, graph functions 1 to 6 were already covered during your grades 8, 9, and 10. So what's new today will be on number 7, 8, and 9. Now let's start with the first one, linear function. The keyword is line. Now, a function is a linear function when the highest exponent is 1. Again, the highest exponent for the variable is 1. Let us remember that f of x is just the same as y. So if you see y equals mx plus b, it's the same as f of x equals mx plus b. Let's have an example. Here, you check 3x plus 4. So the exponent, you cannot see it, it's 1. So it's a linear function. The other is y equals 2x minus 8. What's the exponent of x? It's 1. Therefore, this is a linear function. The graph of a linear function is a line. The next type. The next is what we call the quadratic function. Now, what will be our keyword for the quadratic function? In the quadratic function, here, the exponent of x is 2. Again, the exponent of x is 2. And y must only have an exponent of 1. You already have your, for STEM students, you already have your pre-calculus, the last shift, in shift 1. And you know that it's still quadratic when we have x squared plus y squared equals 1, right? It's of a circle. But it's a quadratic equation, but it's not a quadratic function because y has a power of 2. Again, for quadratic function, only x should have a power of 2. Examples. Here, 3x squared, the square, and 2x squared. The 2 there is your hint. Next, the third type. For the constant function, there's no x variables. What we only have is the constant or the constant term. So example, f of x equals 4 or y equals negative 8. So we only have here our constant terms. That's why we call it constant function. Next, the fourth one. The fourth type is identity function. How do you know it's identity function? If the left-hand side is the same as the right-hand side. Example, there's only one type of that. It's just f of x equals x. Example, f of x equals x, or y is equal to x. That's for the identity function. The next type is the absolute value function. Now, what is in the absolute value function? You will see the variable inside the absolute value bars. Example, here, absolute value of 3x plus 4. The other one, absolute value of 5x minus 8. Ma'am, what if there's an absolute value, but the variable is not in the absolute value bar? Example, absolute value of 4x plus 2. There. Now, if you'll see, we have an absolute value bar, but only the number is inside. The variable is outside. Therefore, this is not an absolute value function. Instead, this is just a linear function. Let's go to the next one. Rational function. Now, what's a rational function? In the rational function, we have the numerator and the denominator as both polynomial functions. Example, here, the numerator is a polynomial function. Denominator is a polynomial function. In the second one, the numerator is a polynomial function with only a constant term 4, while the denominator is also a constant function. Now, what's the graph of a rational function? We have this one, the asymptotic lines. We'll talk more about this in the second chapter. We have a full chapter for rational functions. The next type is the exponential function. In the exponential function, you will see the variable in the exponent. Again, the variable is the one in the exponent, not in the base. Example, 2 to the power of x, or 5 to the power of x plus 2. Ma'am, what will happen if we'll make it this one? X squared. If it's 2 to the power of x, it's exponential because the exponent is a variable. But if the exponent is a base and if the base is a variable and the exponent is 2, then we call it quadratic. Remember, 2, quadratic. Now, the next one is logarithmic. In a logarithmic function, your keyword is the log. That's logarithmic. Log of 5 of x, or 2 plus log of 3 of x. So the log word there is your key, is your keyword. Now, the logarithmic function is the inverse of the exponential function. If you'll check the graphs, the exponential will look like this, while the logarithmic will look this way. So they are the exact opposites. We'll talk more about logarithmic and exponential in chapter 3. Again, we have a whole chapter for that one. The last one is the piecewise function or a compound function. How do I say this? To simplify it, a piecewise function has a condition. Example, like this one. The value of your f of x or of your y, the value of your y is 2 if x is greater than 4. Or the value of your y is -5 if x is less than -4. Now, that is what we call piecewise function. Or let me share to you some real-life applications. Sometimes your parents will tell you, okay, we will have a condition for your allowance since we have an online class this time. Your allowance will be 500 if the grade is, let X be our grade. If your grade is greater than 90. If greater than 95, then you can get 1,000. If less than 90, then you will just have 200. So now, that is how a piecewise function works that way. Let's have a very brief review. Again, the types of functions. The first is linear. The exponent is 1. Quadratic, the degree is 2. Constant, no x, okay, just a constant term. Identity, y is equal to x. Next, absolute value. The variable is found in the absolute value bar. The next is rational. The numerator and denominators are both polynomial functions. Exponential, the exponent is a variable. Logarithmic, we have the logarithmic sign. Then the piecewise, we have some conditions. So that ends today's discussion for functions.